In this video, our focus is to convert a proper fraction in which the denominator consists of linear factors into its partial fractions. So let's get started with the question. Let's look at this example. 6x minus 2 divided by x minus 3, x plus 1. This is a proper fraction. What's a proper algebraic fraction? A proper algebraic fraction is one in which the highest power of the numerator is lesser than highest power of denominator. The highest power in this scenario is 1. The top is a linear expression. The bottom is two linear expression multiplying it out, making it a quadratic expression. Since the highest power of the numerator is lesser than highest power of the denominator, therefore it's a proper algebraic fraction. When we talk about partial fraction, we divide it into different cases. So when we are talking about case number 1, we are only focusing on the denominator. Why? Because it's already a proper fraction. That will be our case with case number 2 and case number 3. Again, the focus will be on the denominator because the fractions are proper. Let's continue with the same question. 6x minus 2 over x minus 3, x plus 1. The denominator consists of two linear factors. In other words, originally there were two fractions from which this single fraction was made. One of them has a denominator of x minus 3. The other one has a denominator of x plus 1. What is missing? The numerator for the first fraction, let's call it a. The numerator for the second fraction, let's call it b. Our objective is to find these unknown constants a and b. How should the question be solved? Take LCM on the right hand side. X minus 3, x plus 1. A will be multiplied with x plus 1. The plus sign is already there in the middle. And this b will be multiplied with x minus 3. Now both sides are identical. Both sides consist of a fraction on either side. The denominator equals the denominator. Therefore, the numerator should equal the numerator. So therefore, 6x minus 2 is identical to a multiplied with x plus 1 and b multiplied with x minus 3. So now we can use the process of substitution to solve for unknown constants a and b. Let x equals to negative 1. So 6 into negative 1, negative 2. A multiplied with negative 1 plus 1. This will become 0. B multiplied with negative 1, negative 3. Negative 8 on the left equals to negative 4b on the right. Therefore, b comes out to be positive 2. Now, our focus is to find the other constant, which is a. Let x equals to 3. Why am I choosing 3? Because 3 minus 3 will make it 0 and b will disappear. 6 into 3 minus 2, that is identical to a times 3 plus 1, b times 3 minus 3, and thus becomes 0. So therefore 18 minus 2 is 16, that is equals to 4a. Therefore a comes out to be 4. Now let's stop and pause for a second. What are we actually after? We are actually after solving a fraction into its original fractions, which are called partial fractions. So a is the numerator of x minus 3, and the value of a came out to be 4. So therefore the final answer is 4 over x minus 3. The value of b came out to be 2 over x plus 1. This is the final answer. These are the partial fractions for which the whole working was done. So that is the first example to solve a question related to partial fractions. Let's move on and solve some other question. Something like 6x squared plus 5x minus 2 divided by x squared minus x and 2x plus 1. Now, one other thing that you have to observe is that always factorize the denominator. So when we factorize the denominator, it could either be by taking common, or it could be by factorization. It could be middle term, it could be difference of two squares. Over here, this is simply taking common. X squared minus x is simply x minus 1. It was a simple working. So therefore, this question would proceed like this. 6x squared plus 5x minus 2 divided by x minus 1, 2x plus 1. How many factors do you see? This is 1. This is the next one. This is the third one. That means this final answer, this what I'm referring to as the final answer, this was created out of 3 fractions. What were those 3 fractions? What were the denominators? The denominators were x minus 1 and 2x plus 1. The numerators could be written as a, b and c respectively. Now let's start taking LCM. So the LCM is x minus 1, 2x plus 1. A is multiplied with x minus 1, 2x plus 1. B is multiplied with x, 2x plus 1. Basic algebra from basic math. And C is multiplied with x minus 1. Now this whole numerator equals to this whole numerator. Left hand side numerator equals to right hand side numerator, because both sides are identical. The denominators are already the same. So therefore the numerators should also be equal. So 6x squared plus 5x minus 2 is identical to a times x minus 1, 2x plus 1, b times x, 2x plus 1, c times x minus 1. One at a time. That is our approach in which we will apply the concept of substitution to solve for these unknown constants. Let's start off by saying let x equals to 0. When x equals to 0, negative 2 equals to a multiplied with negative 1 and positive 1. So therefore a comes out to be 2. That is the first unknown constant that is obtained. Let's choose let x equals to 1. 6 plus 5 minus 2, that is equals to, which two brackets will disappear? X minus 1, and we are only left with b multiplied with 1, and this is 3. So therefore 9 equals to 3b. Therefore b comes out to be 3. That is the second constant. So we achieved a. We achieve success in solving for A and solving for B. Now let's try and solve for C. So which values have we used? We have used 0. This disappears, and we found A. We then chose x is equals to 1, and then we disappeared a, and we made c disappear, and we found the value of b. So now the focus is finding the value of c, and this is where the solution lies. Which value of x will make 2x plus 1 disappear? So I'll write 2x plus 1 equals to 0, x is equals to negative half. Now let x equals to negative half. When x equals to negative half, so we have negative half whole square is multiplied with 6. 5 is multiplied with negative half minus 2. That is identical to a disappears, b disappears, c is multiplied with half, and negative half and negative half minus 1. So this is 6 over 4. This is negative 5 over 2, negative 2. Let me simplify this. 3 over 2 minus 5 over 2 minus 2. So that becomes negative 1, negative 2, that is negative 3. So this is negative 3. And over here, this is c into negative half, negative 3 over 2. That is c multiplied with positive 3 over 4. So this is negative 3, this is positive 3 over 4, therefore c comes out to be negative 4. And don't forget that in questions related with partial fraction, you have to write the final answer. We have a is 2, b is 3, and c is negative 4. So a is 2, and b is 3, and c is negative 4. So this is how the final answer will look like, that is breaking it up into its partial fractions. So now in this particular video, we have focused on case 1 of proper fraction, proper algebraic fraction, in which the denominator consisted of linear factors. If it's 2 linear factors, there were 2 original fractions. If it's 3 linear factors, like in this case, there were 3 original fractions. The numerator in each case was a constant, which was found using the process of substitution.